Good morning, children. This class we are going to discuss about the discovery of protons, properties of anode rays, discovery of neutrons, and then properties of neutrons, properties of fundamental particles. Okay, that is already we have discussed about the electrons. So this class we are going to discuss about protons as well as neutrons and their properties, followed by Thomson's atomic model. What are the limitations of Thomson's atomic model? Valency, types of valency, and valency with respect to atoms like hydrogen, okay, and then oxygen, chlorine, followed by variable valencies. So this class we are going to discuss all about this, right? First we can move to discovery of protons. What are the fundamental particles? The fundamental particles are protons, electrons and neutrons. Then what are protons? Protons are positively charged particles which are present at the center of an atom, right? Protons are, I told you protons are positively charged particles. The entire mass of an atom is concentrated in the center of the nucleus. The center part is called nucleus. Okay, so the entire part of the atom is concentrated at the center part, that is called nucleus, right? And protons are, very well, you might have learned in your lower classes. Protons are positively charged particle. Electrons are negatively charged particle, whereas neutrons are no charge, that is they are neutral in nature, right? Protons and neutrons are present at the nucleus. Nucleus is present at the center of an atom, isn't it? So protons and neutrons are present at the center of an atom, that is called nucleus, whereas electrons revolve around the nucleus in circular orbits. Okay, electrons revolve around the nucleus, whereas protons and neutrons are present at the center, that is called nucleus. The number of protons and electrons are equal in an atom. Okay, so in an atom, the total number of protons as well as electrons are equal. That is why an atom is electrically neutral. Understood, children? Shall we move to the next one? Right. Next we can move to the discovery of protons. Okay. Goldstein discovered protons. Goldstein, by using the discharge method that already in the last class we have discussed about the cathode ray tube experiment, isn't it? So in that we discussed about the discharge tube, isn't it? So here also Goldstein, by using the discharge tube, Goldstein discovered proton. So Goldstein, by using this discharge tube, he passed a high voltage electric source. Okay, he passed high voltage electric source which had a perforated cathode. Perforated means small hole will be there. Okay, small openings will be there. So he conducted an experiment by using the discharge tube which had a perforated cathode. He observed that faint means a little bit light color. Okay, he observed a faint luminous glow, red glow. He observed faint luminous red glow which was seen on the wall behind the cathode. Here the rays were traveling in the opposite direction of the cathode. Hence he termed these rays are called anode rays or positive rays or canal rays. Got it, children? Once again I repeat. Goldstein conducted an experiment by using the discharge tube. He took up with the perforated cathode. Perforated means small openings. Okay. He observed a faint red glow, luminous red glow. Luminous means what? It shines in the dark. Even in the dark, it shines. Okay, that is called luminous. So he observed faint luminous red glow which was seen on the walls behind the the cathode. So these rays were traveling in the opposite direction of the discharge tube, opposite direction of the cathode. Okay, so these rays were traveling in the opposite direction of the cathode, and hence we called as positive rays or canal rays or anode rays. Got it, children? Right. So next, properties of anode rays. What are the general properties of anode rays? Anode rays always travel in the straight line. Got it? Anode rays travel in the straight line. That's a very important point. Next one, anode rays are made up of particles. Particles means what? It is very small. Okay, particles means very small in nature. Minute particles means it is very small. So anode rays are made of particles, right? Next, anode rays are deflected by both electric field as well as magnetic field. Okay, deflection means what? It changes its direction. So anode rays are deflected by both electric field and magnetic field. Right, children? Right. Hence, anode rays are deflected by both electric and magnetic field. Hence, it contains positively charged particle. Right. That's why we are saying protons are positively charged particle. Right. Good. And okay, now we can move to the discovery of neutrons. James Chadwick discovered neutrons, right? So neutrons are actually, they have no charge, they are neutral in nature, they have no charge, okay? The mass of the neutron is equal to 1.6 into 10 to the power minus 24 grams, okay? And also, our tabular column we have to see the properties of fundamental particles. This tabular column is important. One more question you may get from this, right? Okay. So look at this one. These are the some properties, that is particles, subatomic particles they have given. Their mass as well as relative charge is given, right? So first one, if you take the electron, it is represented by the symbol E. Small letters you have to use for electron. Got it? Right. So electron, its mass is 9.1 into 10 to the power minus 28 grams. Okay, so this is the mass of electron, whereas its relative charge is minus 1 because electrons are negatively charged particle, isn't it? Protons are positively charged particle. Electrons are negatively charged particle, whereas neutrons are no charge. So electron, its mass is 9.1 into 10 to the power minus 28 grams, and its relative charge is minus 1. Next one, proton, it is represented by the letter P, small p, right? So its mass is 1.6 into 10 to the power minus 24 grams, and its relative charge is plus 1 because protons are positively charged particle, right? Next, neutrons, it is represented by small n. Okay, so its mass, that is the mass of neutron is 1.6 into 10 to the power minus 24 grams, and its relative charge is 0 because neutrons are neutral in nature, they have no charge. Got it, children? Right. These are the properties of fundamental particles. Right. Next we can move to Thomson's atom model. Okay, so this is very important. When you go to higher classes, you will learn elaborately about the Thomson's atomic model. Right. Thomson's atom model is compared to watermelon. Otherwise, we can say Thomson's atom model is otherwise called as plum pudding model or watermelon model. Okay, so look at this one. This is the plum pudding model and watermelon model. Here, the electrons were embedded. It represents the seeds of the watermelon, whereas the red mass of the watermelon represents the distribution of positive charge. Got it, children? Thomson's atomic model, it compared with the watermelon or plum pudding model. Okay, here the electrons were, these are nothing but the electrons. Here the electrons the embedded electrons, it resembles the seeds of the watermelon, whereas this red mass, this This mass of an atom, this red mass is compared, it is nothing but the mass of an atom is fully, that is uniformly distributed all over the atom. Okay, the mass of an atom is uniformly distributed all over the atom in the plum pudding model. Got it, children? So Thomson's atomic model is compared to what? Right. One is the watermelon and another one is the plum pudding model. Got it, children? At the same time, there are some limitations in Thomson's atomic model. That is, in this atomic model, some limitations are there. What are the limitations? This Thomson's atomic model, it failed to explain the stability of an atom, right? Next, this model, it failed to explain the scattering of alpha particles by thin metal foil. Got it, children? These are the two limitations of Thomson's atomic model. Got it? Right. So next we can move to the valency. First you should know about the fundamental particles. You know the fundamental particles. The fundamental particles are protons, electrons as well as neutrons. So protons are positively charged particle, electrons are negatively charged particle, whereas neutrons are no charge. Isn't it? Right. Here, the protons and neutrons are present at the center of an atom called the nucleus. Isn't it? Center of an atom is nothing but nucleus. Whereas electrons revolving around the nucleus in circular orbits, isn't it? Circular orbits. Hence, an atom consists of many orbits or shells. Okay. So, the electrons revolving in the circular orbits of an atom. The electrons revolving in the circular orbits of an atom are called the valence shell. Okay, this is called the valence electrons, we can say. So look at this one, arrangement of electrons in an atom. Look at this diagram, children. Here this is an atom. Here this is the center part. This is called the nucleus. Inside the nucleus what is present? Protons and neutrons are present. These are the electrons revolving around the nucleus. Isn't it? In circular orbits. Here this is the first orbit, second orbit as well as this is the third orbit. So for this atom, this third orbit is the outermost orbit. Here some electrons are revolving now. So these electrons are called the valence electrons. Got it, children? So the electrons revolving in the outermost orbit of an atom are called the valence electrons. Got it? Right. So next we can when atoms are when molecules are combined, okay, when molecules are combined in a fixed proportion. Why? Because atoms, they have different combining capacity. Okay, so valency means the combining capacity of an atom is called the valency. Okay, when molecules are formed, due to this, atoms, they combine in a fixed proportion because atoms have different combining capacity. So the combining capacity of an atom is called valency. Okay. There are two types of valency. One is the positive valency and another one is the negative valency. What is the difference between these two valency? Before that, we should learn about the electronic configuration. So what is meant by electronic configuration? The arrangement of atoms in various shells of an atom of the element are called the electronic configuration of an element. Okay, what is meant by electronic configuration? The arrangement of atoms in various shells of an atom. So this is one shell, this is one shell and this is one shell. So the arrangement of atoms in various shells of an atom of the element is called the electronic configuration. Now come to the valency. Already I discussed valency means the combining capacity of an atom is called the valency. There are two types of valency. One is the positive valency, another one is the negative valency. First, if you take the positive valency, okay, here the atoms which donate electrons are said to have the positive valency, right children? Atoms which donate electrons are called positive. Which donate electrons are called positive valency. For example, if you take the sodium element, okay. For example, sodium element, atomic number of sodium is 11. The atomic number is based on the number of protons, isn't it? So number of protons is nothing but the atomic number of the particular element. Okay. So sodium atomic number is 11. So, in order to attain the stability position, stable position in the electronic configuration, sodium atom, it donates one electron, that is, it loses one electron. Okay, it loses one electron. Then only it attains the stability position in the periodic table. Okay, so this is called the positive valency. Hence, sodium atom is an example of positive valency. Okay, once again I repeat, positive valency means atoms which donate electrons are called said to have the positive valency. For example, sodium atom, it consists of 11, its atomic number is 11. So, to attain the stable position, it loses one atom, then only it can attain the stable position in the electronic configuration. So, sodium atom is a positive valency. Next, we can move to the negative valency, right? Negative valency means atoms which loses electron. Okay, that is atoms in the positive valency. What we saw, atoms which donate electron, it loses electron. Here in negative valency, it is not like that. Atoms which get the electrons, okay, from other atom. This is called, that is, it gains the electron. This is called the negative valency. Okay. Atom which gains electron are said to have the negative valency. For example, you can take the chlorine atom. The atomic number of chlorine is 17. Okay, so this is the electronic configuration of chlorine. Atomic number of chlorine is 17. So, to attain the stable position in the electronic configuration, chlorine atom gains one electron. Okay, it gains one electron, then it is said to be the negative valency. So, chlorine atom is said to have the negative valency. Chlorine atom is an example of negative valency. Positive valency means atoms which donate electrons, whereas negative valency means atoms which gains electrons. This is the difference between positive valency and negative valency. Understood, children? Right. So, next we can move to types of valency. Okay, valency with respect to atoms, that is hydrogen, chlorine, oxygen are given. One by one we can see now. First one, let me move to the valency with respect to hydrogen. Okay, so valency of an element is defined as the number of hydrogen atoms which combine with one atom of it. Right? For example, if you take the hydrogen chloride, okay, if you take the hydrogen chloride molecule, one atom of hydrogen combines with one atom of chlorine. Hence, the valency of chlorine is 1. Got it, children? Right. Next one, chlorine. And even you can take the water molecule. You know very well water is composed of hydrogen as well as oxygen. Here, 2 hydrogen atoms combine with one oxygen atom. Here, the valency of oxygen is 2. Okay, so these are the valency with respect to hydrogen, right? So next we can move to valency with respect to chlorine. Okay, before that you should know that all the elements will not combine with the hydrogen. Okay, some elements may combine with oxygen as well as chlorine. Most of the elements combine with oxygen as well as chlorine. Okay, that elements will not combine with the hydrogen means those elements will get combined with oxygen as well as chlorine. For example, we can take the sodium chloride molecule. Okay, sodium chloride. Here, one atom of sodium combines with one atom of chlorine to form sodium chloride. Here, the valency of sodium is 1 only, right? So next one, oxygen combines with oxygen. Oxygen, and also for chlorine, magnesium chloride also we can take as an example. One atom of magnesium combines with two atoms of chlorine to form the magnesium chloride molecule. Here the valency of magnesium is 2 because it combines with two chlorine molecule, right? Next we can move to the valency with respect to oxygen. Here MgO is nothing but magnesium oxide. One atom of magnesium combines with one atom of oxygen. Even though the one atom of magnesium combines with one atom of oxygen, its valency is said to have 2. Why? Because here the double the number of oxygen atoms. Because of this, valency of oxygen is 2 here. Understood, children? Right. So next we can move to the valency of atoms, right? See, molecule is given, element is given, as well as valency is given. First one, if you take the hydrogen chloride, and the formula of hydrogen chloride is HCl, right? So its element is chlorine, and the valency is 1 because one atom of hydrogen combines with one chlorine atom. So the valency of chlorine is 1. Next one, if you take water, it is composed of hydrogen as well as oxygen, that is 2 hydrogen atom and 1 oxygen atom. Its element is oxygen, whereas its valency is 2. Okay, because one atom of oxygen is combined with 2 hydrogen atoms, so its valency of oxygen is 2. Next one, ammonia, that is nitrogen as well as hydrogen. One atom of nitrogen combines with 3 atoms of hydrogen, and its element is nitrogen. Okay, valency is 3. Why? Because one atom of nitrogen combines with 3 atoms of hydrogen, so the valency of nitrogen is 3. The next one is methane. Methane formula is CH4. Okay, carbon as well as hydrogen atoms. Here one carbon atom combines with 4 hydrogen atoms, and the element is carbon, so its valency is 4. Like that you have to calculate the valency of atoms, right children? Good. So next we can move to variable valency. Okay, so variable valency means what? Here atoms of some elements combines with atoms of other element to form one or more products. This is called the variable valency, right children? What is meant by variable valency? Variable valency means atoms of one type of atom is combined with another type and forms 2 or more products. Okay, this is called the variable valency. So in that case, you will get 2 or more products. For this, sometimes we can use those products in we can mention those products in Roman numerals also. Okay, and here variable valency means what? Atoms of one element combines with atoms of other element to form more than one product. For example, if you take cuprous oxide, that is copper, when it is treated with oxygen, okay, it forms 2 products, not a single product. Copper when it treats with oxygen, or otherwise copper when it reacts with oxygen, it forms 2 products. One is the cuprous oxide and another one is the cupric oxide, right? Cuprous oxide, its formula is Cu2O, whereas for cupric oxide its formula is CuO. Okay, here for cuprous oxide the valency of copper is 1, whereas for cupric oxide the valency of copper is 2. Like that we have to calculate the variable valency. Okay, variable valency means atoms of one element combined with another element to form more than one product. For example, an element is given, cation is given, names are given. Okay, here copper element is given and its formula is Cu, copper element, Cu2 products we will be getting. One is the cuprous as well as another one is cupric. Okay. For higher valency means you have to add the prefix, that is OUS at the end of the name of the metal. Whereas for lower valency means you have to add the prefix IC at the end of the name of the metal, like this. So Cu plus, its name is cuprous or copper 1. Copper 1 means 1, you have to mention it in Roman letter, right? So next one for Cu2 plus, that is cupric or copper 2, Roman letter. Everything you have to mention it in Roman letter. Next one iron, right? Fe2 plus as well as Fe3 plus. So this valency is higher valency, 3 plus, isn't it? So we have to add Ic. Okay, suffix we have to add, this prefix we have to add Ic. Ferrous or iron 2 or here ferric or iron 3, right? So next one is, what is given? Next one is mercury. Yeah, next one is mercury. Here Hg plus as well as Hg2 plus. Which valency is high? Hg2 plus is higher, isn't it? So we have to add Ic. Here for Hg, mercurous or mercury 1. For Hg2 plus, mercury or mercury 2. Right? Good. So next one is chain. Tin is Sn2 plus as well as Sn4 plus. So which valency is higher? 4, isn't it? Okay. So for Sn2 plus, stannous or tin 2, whereas Sn4 plus, stannic or tin 4. Here one thing you have to remember, children, you have to add the suffix. If valency is higher means you have to add OUS. If valency is lower, okay. If lower valency is lower means you have to add OUS, whereas valency is higher means you have to add IC, suffix at the end of the name of the metal. This is a very important point about the variable valency. Okay. So what are the elements? Copper, iron, mercury, tin. You will be getting Cu plus as well as Cu2 plus. Cu plus is the here the valency is low. That is only one valency. This Cu plus contains one valency. So we have to you have to add the suffix OUS at the end of the name of the metal. Whereas valency high means you have to add IC. Here if you take the tin element, Sn2 plus as well as Sn4 plus you got, isn't it? So 4 valency is high when compared to 2, isn't it? That's what we are adding IC suffix here, and for Sn2 plus we are adding OUS suffix. Okay, children. So in this manner we have to calculate the variable valency, right? So what are the things we discussed today? Discovery of protons, properties of anode rays, discovery of neutrons, then properties of neutrons, followed by properties of the fundamental particles and Thomson's atomic model. Okay, and followed by the limitations of Thomson's atomic model, valency, types of valency, and then valency with respect to hydrogen, oxygen as well as chlorine, and also we discussed about the what is this variable valencies. These things you have to remember, right, children? Good. We can discuss about ions in the next session. Complete just to go through everything. Okay, children, and you have to write the properties of fundamental particles and Thomson's atomic model diagram, that is watermelon diagram, as well as plum pudding model diagram you have to draw. This is your assignment. So complete the assignment, children. We will see the remaining things in the next session.